Hey kids, Mr. Murray here, Mr. Murray's Mathland, and we are talking about a new kind of factoring today, and this would be factoring a trinomial, so three terms, a trinomial where the leading coefficient is 1. So just starting off with x squared or y squared or a squared or whatever variable you might be using here. Okay, so here's really the main thing you're going to be looking for. It's a pattern. I call it just the unfoiling pattern because you typically get a trinomial like this when you foil to binomials. But the two things you're going to have to figure out are you're going to have to come up with two numbers. And these two numbers have to do two things. The two numbers have to multiply to be whatever the constant is on the end, whatever c is. So the two numbers have to multiply to be this, and they have to also, the same two numbers have to add up to be this. Okay, so let's see what we mean by this. In this first example, we are trying to factor this, and factoring, of course, means try to figure out what multiplies to give you this expression. There's no greatest common factor I can take out of all three terms, and I only try grouping, that other method, when there are 4 or more terms. So this is the unfoiling pattern, as I call it. It doesn't really have a good name. You see a trinomial, you know it's going to unfoil to two binomials, and the key is that if it starts with x squared, nothing out in front, not a 2x squared, a 3x squared, anything else, just plain old 1x squared, then I know what goes here in the two sets of parentheses is x times x, because my first step in the FOIL is x times x, and that gives you the x squared. The thing I have to figure out next is what two numbers go here and here, and that's this pattern that I'm talking about. So I'm trying to find, in this problem, two numbers. I'm just going to make a blank. The two numbers have to multiply to be what's on the end, that 20. Two numbers that multiply to be 20, but those same two numbers have to add up to be what's in the middle, which is 12. Now, if you're really good with your times tables, it probably shouldn't take you too long to come up with that. And if you're not so good, then you might have to make a list of the factors of 20. What are the things that multiply to give you positive 20? Well, 1 and 20, 2 and 10, 3 doesn't go in, 4 and 5, and that's really it. So which of these will multiply to 20 and also add up to 12? And that is going to be 2 and 10. So 2 and 10 multiply to be 20, and 2 and 10 also add up to be 12. Notice that the signs are very important also. So the first example we're talking about here, they have to multiply to be positive 20. Now, two numbers multiplying to be a positive number tells you they've got to be the same sign, either both positive or both negative. And if they're adding up to be a positive number in the middle, and they're the same sign, then that means they've got to both be positive. So here we go. My answer is going to be x. Positive 2 was one of the numbers. Positive 10 was the other number. And there we go. That's my answer. The order doesn't matter in which you wrote them, so you could have written the plus 10 here and the plus 2 here. That's fine as long as the signs are correct. And remember, how you can always check is by multiplying it out. And it's really not a bad idea when you do these for the first time to check by foiling. So if you multiply this out, your first will give you x times x is x squared. Your outers, x times 10, will give you 10x. Your inners will give you 2 times x, which is 2x. And your last, 2 times 10, will give you 20. So you can kind of see where this pattern comes from. That 20 came from doing 2 times 10. And in the middle, where did that 12 come from? From adding those two, because whenever we FOIL, a lot of times we get that combination in the middle there, right? The like terms that add together to give you the middle. So You got what you started with, you know that's the combination. Okay, coming up with the two numbers is going to be what will take most of you the most time probably. So, be good with your times tables. This is a chance to brush up on them. It'll go faster and faster. So here we go. X squared minus 14x plus 49. So again, there's no greatest common factor I can take out. 3 terms. I'm going to try to unfoil this. It starts with just x squared. That's good. That means I can just go x and x. And now I'm looking for two numbers that multiply to be. Two numbers, they have to multiply to be that positive 49. So I know they have to be the same sign, either both positive or both negative. But what do they have to add up to be? The number in the middle, negative 14. And if they're the same sign and they're adding up to be a negative, that must mean that they're both negative, right? And so what multiplies to positive 49 and adds up to negative 14? Negative 7 and negative 7. So what do I write for my answer? X minus 7, and in the other one, x minus 7. There we go. There's my answer. It would be just fine to leave the answer that way, but you will encounter these sometimes, and if it's the same quantity twice, x minus 7, x minus 7, a lot of times that will be written in a simpler form. That's like saying x minus 7 squared. It's a little bit of a more professional way to write that answer, and you all want to be professional mathematicians, right? So x minus 7 squared. This is what we call a perfect square trinomial because it was found by doing x minus 7 squared. Okay, just see a couple more, and that's really it though. It's just that pattern of coming up with those two numbers. So number 3 here, I see it's a trinomial. I'm going to try my unfoiling pattern. Starts with x squared. Pretty soon it will not, but for right now, when it starts with x squared, that means I can go x and x and just focus on what is going to multiply to give me negative 56, the number on the end, the constant on the end. And when they multiply to be negative 56, that means one of the numbers has to be positive and one has to be negative. Okay, so think about that. Now those same two numbers have to add up to be the coefficient in the middle, and remember we don't see a coefficient there. That's really a 1, right? That's in front. So I'm looking for two numbers that multiply to be negative 56 and add up to be positive 1. Okay, so if you're thinking of things that multiply to be 56, just remember one of them is going to be positive and one's got to be negative. And if you don't know your times tables, you can't just come up with this right off the top of your head. Be systematic. Make a list and go in order. Start with 1. 1 goes into everything. 1 and 56. But one of them would have to be positive and one would have to be negative. So the bigger one in this case would have to be the positive one because it's also adding up to be positive 1. So think about negative 1 and positive 56. Obviously, that's going to add up to positive 55. That's not what you want. So think about making this number a little bit bigger. How about negative 2? And that's 28. Negative 2 and positive 28 would add up to positive 26. Does 3 go into 56? No, it does not. Does 4 go in? Yes, it does. And if you don't know this, you can test with your calculator. But again, make the smaller number the negative one because it's adding up to be a positive number. So the bigger one has to be the positive one. And so 4 times 14. So negative 4 times positive 14. That adds up to be positive 10. So we're getting closer to being positive 1. 5 doesn't go in. 6 doesn't go in. 7 goes in. 7 and 8. And again, if you make the bigger one the positive one, what does negative 7 plus 8 give you? Positive 1 when you add them, and they multiply to be negative 56. So that's the combination you're looking for. Negative 7 and 8, negative 7 and 8. And so what do we write here in the parentheses? X, one of them has to have minus 7. Doesn't matter which one, as long as the 7's negative. And the other one has to have positive 8. So plus 8. Just remember, the order could be reversed, so you could have x plus 8, x minus 7, but the 7's got to be the negative one and the 8's got to be the positive one. Check by foiling. Can't say it enough. It's not a bad idea. Can check every time. All right, and one last here. X squared minus 7x minus 60. It's a trinomial, so I'm going to unfoil it. Starts with x squared, so x and x. Just focusing on those two numbers. What two numbers multiply to be negative 60? So again, one's got to be positive, one's got to be negative. But these same two numbers have to add up to be what's in the middle there, and that is negative 7. So in this case, one's got to be positive, one's got to be negative to multiply to give you a negative. And if the signs are different and they're adding up to be a negative number, that means the bigger of the two numbers has to be the negative one, and the smaller one's got to be positive, right? So these are just little tricks that can help you kind of go through the choices a little bit faster. Again, if you can just come up with the combination right off the bat, some of you will be like that. Some people are just faster than others. That's always going to be the case. But if not, if you get a bigger number you don't know, you just be systematic. 1 goes into everything, right? 1 and 60. But again, one's got to be negative, one's got to be positive, and in this case, the bigger one's got to be the negative one. The smaller one's the positive. Those would multiply to be negative 60, but they would add up to be negative 59. So we're way far from adding up to negative 7. So how about positive 2? 2 and negative 30, that adds up to negative 28. No good. Does 3 go into 6? Yes, 3 goes in, negative 20. But those add up to be negative 17. Does 4? 4 times 15. So positive 4 and negative 15 will add up to be negative 11. Getting closer. Does 5 go in? Yes, it ends in zeros. 5's got to go in. 5 and 12. So negative 12 and positive 5, that adds up to negative 7. There's your combination you're looking for. It's got to be positive 5 and negative 12. Positive 5 and negative 12. So what do we write? X plus 5 and x minus 12. And there we go. There's our final answer. Check by foiling. And hopefully you got a good sample of the pattern here, so you feel comfortable doing these on your own. If you have any questions, just feel free to ask. Take it easy, kids.